All right, so let's look at another example of solving a simple trig equation. And once again, simple just means we're not using trigonometric identities. As I teach those, we're going to add those into these solves. So I have a fairly basic problem to go ahead and solve. We've got 6 cosine squared theta minus 3 equals 0. And at first I want the general solution. So let's find the general solution to this. So here I'm going to add 3 to both sides. I've got 6 cosine squared theta equals 3. I'm going to divide by 6, and I have cosine squared theta equals 3 over 6. Reduce your fraction. Cosine squared theta equals 1/2. I need to take the square root. Now you have to remember, every single time you take the square root, you must put the plus or minus. So I'm going to have cosine theta equals plus or minus the square root of 1/2. Now this means the square root goes to the top and the bottom. So I have cosine theta equals plus or minus the square root of 1 over the square root of 2. When you do this math, you end up getting cosine of theta equals plus or minus the square root of 2 over 2. All right. Now, we want to get theta by itself. We can just simply move this over. Theta equals arc cosine of plus or minus the square root of 2 over 2. All right, now we got to think, okay, well, wow, we got plus and minus in here. That's a bit of an issue. We know that's going to be in quadrant 1 and quadrant 2 for arc cosine. But we also know cosine being plus or minus. Well, let's just do that. Let's do the plus or minus here. So I'm going to be able to say theta equals. Now let's do it like a piecewise function. Let's address the positive square root of 2 over 2. Well, this is pi over 4. Now let's address the negative square root of 2 over 2, and this is 3 pi over 4. And we know we're going to have to add something to it. In this case, I'm still just going to add pi because it's from quadrant 1, we just add 180 degrees or pi to get to the quadrant 3 version. And here I can add pi, go from quadrant 2 to quadrant 4. I'm going to do pi k such that k is an element of the integers. If you don't tell me what k is, you're wrong. Pi k such that k is an element of the integers. And here is my general solution to this equation itself. So if I'm asking for a general solution, I'd be looking for something like this. Now, what if I say I want this answer between, let's say, 0 degrees to 360 degrees? Now, if you notice here, I got a curved bracket. If you remember for interval notation, that means we would not include 360, but we go right up to it as close as we possibly can. And then, of course, we have 0 degrees. What's really nice is I can just know the unit circle, and from right here, I can get my answer. I don't need to use this. You can plug 0 in, 1, 2, 3, 4 for your k's on both of these, and you would get the same answers. But these answers coming from the unit circle, my theta for this part is going to be 45 degrees. Remember, if I give this to you in degrees, I want the answer in degrees. 135 degrees, 315 degrees, I'm missing one, 225 degrees. And voila, there are my 4 answers. These are for the interval from 0 to 360. So you always have to pay attention to the interval, what you're going to give me the answer. Now, if you put 0 in here, you get your pi over 4 or the 45 degrees. If you put 1 in here, you are going to get 5 pi over 4, which is your 225 degrees. If you put 0 in here, you get your 3 pi over 4, which is 135 degrees. And if you put your 1 here, you're going to get 7 pi over 4, which is your 315 degrees. Not terribly bad. As of yet, not terribly bad. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.